hydrogen would be similar in the nitrile group, in the nitrile case, and the carbonyl case. So like the hydrogen next to a ketone is around 25 as well. So now if we look to this is a more simple, okay? This is just an amine, and the pKa for the hydrogen on the amine is 38. And because it is a higher pKa, it is a more stable acid, okay? So it is less acidic, and equilibrium will always lie to the side with the less acidic molecules, okay? Because it is more stable. It is a more stable acid. Now, Oreo does not follow pKa. pKa, you have to understand, it is hard facts. It is lab data. It is what people observe in the lab under controlled conditions. People got those values. The pKa is like describing just the way the world works. This is how the world works, period. And you have to follow how the world works, okay? Oreo represent a way for us to explain how that world works, okay? Sometimes Oreo does, well, you know how explanation sometimes does not fit every scenarios, right? You can never say everything is always something. There's some exception, okay? And in this case, Oreo does not follow the pKa, but go with the lab data, which is the pKa, okay? So equilibrium actually lies to the right because we have this side with the higher pKa value, okay? All right, so this would be the arrow pushing mechanism and the product for this first part of the reaction, okay? All right, so let's look at number 2, the second part of the reaction. Now I have you bring in product A and react it with this to form 3 possible products, okay? Now I gave you some information. It describes how I found out something interesting about the products, okay? All of them still have a sharp peak of 2,150, I guess, over centimeters on the IR, okay? So, right, with that information in mind, what the heck is going on? Right, so, okay, let's first bring in product A. So product A, we have 2 resonance structures, right? We have this and this. Now, being that there's a negative charge here, it is most likely a nucleophile / base, okay? Which means this molecule is an electrophile. Now, I don't see any acidic hydrogens here, so this must mean that it is just an electrophile. We're looking at not hydrogen atoms, but carbon atoms to attack, okay? Or atoms where there are partial positives. So again, how do you find all of the potential partial positive atoms? Is you use the good old resonance structures, and I've drawn down here resonance structures. First, this is a charged molecule, and you are dealing with a positive charge, and to start your resonance structures on a charged molecule is, specifically with a positive charge, is you have to bring electrons towards the positive charge. So I bring in the electrons in this pi bond here towards this oxygen, neutralizing it, moving the positive charge to this carbon right here, okay? And then you just keep going with the nearby or adjacent pi bonds, okay? So I move this down here, okay? bringing the positive charge to this carbon, and then move the last pi bond down here. So here are your 4 atoms with the partial positive, okay, in the hybrid, okay? But there are only 3 electrophilic sites, this, and this. Note that this is not an electrophilic site. This is the same case as a hydronium ion, okay? You do not use a nucleophile to attack the oxygen, because you have to keep in mind that the oxygen still has a full octet, okay? It has its full 8 electrons. If you bring in another set of electrons and attack it, it'll break the octet rule. You'll have a Texas oxygen. And in this case, it's the same thing. Okay, I drew in the lone pairs for you guys just so you guys can see that there are already 8 electrons. Okay, so don't attack this unless you want to form Texas oxygen and challenge the whole world of chemistry. But yes, 3 electrophilic sites. Okay, now this is important. Which nucleophile to use? Okay, you can attack it using the lone pairs on this nitrogen, or you can attack it from using the lone pairs on the carbon. This is where the IR data comes into play. I said I saw a peak at 2150. Okay, now this is between 2100 to 2200, which corresponds to peak for a C triple bond C of an alkyne, or the C triple bond N of a nitrile. Now we will not form any alkyne, or we did not start with any alkyne in our molecule, but we do have this nitrile, which would correspond to this, okay? So you would use this as your nucleophile to attack the 3 possible electrophilic sites to form your 3 possible products. Okay, so that's pretty much it for the main part of the problems. One last thing, this is pretty important. Please understand this and how the partial positive is actually on the atoms that are around the sulfur or oxygen, okay?